Okay, the next problem is confidence interval, and let's first look at the example and then we'll go through the theory. So we want to develop a 98% confidence interval for the average miles per gallon for all automobiles. Now remember the data, okay, which is in the descriptive tab. So the data consists of 38 cases of automobiles, and there are these 7 variables: the country of manufacture, the make and model, miles per gallon, weight, drive ratio, horsepower, displacement, and number of cylinders. Average miles per gallon of automobiles manufactured in these 5 countries is what we want. So here our random variable of interest is miles per gallon of cars manufactured in the stated 5 countries. Now mu sub x is the average of x. So that is, in other words, the average MPG of all the cars manufactured in the 5 countries, which we don't know. We don't know the value of mu sub x, but we want a confidence interval for the average miles per gallon. So since we don't have access to the entire population, we take a sample. So the sample we have from the descriptive tab. What is the sample size? So we can use the function count. I've already named the variables. So MPG is the variable. So we have 38 observations. Okay. Now the formula for developing confidence interval is to find the sample mean. The x bar is said to be a point estimate for the unknown value mu, but that point estimate is not going to accurately predict the value of mu. There will be some amount of error, and that error is called margin of error. So we can set the maximum amount of margin of error for a given probability. So for 98% confidence, okay, that is 98% probability, what is the maximum amount of error if we use x bar as the estimate for mu? That is given by t times the standard error of x bar, which is s over square root of n. Okay. If sigma is known, we can use a z distribution, but in most cases sigma will not be known, so this is the formula that we have to use. So we get x bar plus or minus this margin of error that is determined by the given confidence level or probability. In this case, it is 98%. What we're going to do is we're going to use a data analysis command to generate the margin of error. And then finding the confidence interval is a simple matter of x bar plus or minus the margin of error. So we go data analysis, select descriptive statistics. Now we're going to use the data which I have copied into this sheet, miles per gallon, and check labels in first row, and we will put the output starting from here, and we need to check summary statistics and confidence level. So we wanted 98% confidence level, so specify that and click OK. Now we have the data analysis output. Okay, this part was what we originally generated. Okay, let's format that. And since we checked confidence level, the output now includes what is called, what Excel calls, confidence level. This is nothing but margin of error. So 98% margin of error is that value. So our confidence interval lower limit is the mean x bar, which the output already has generated, minus the margin of error. Okay. Then x bar plus the margin of error is the upper limit. So let's go and adjust the decimal places, and that is our confidence interval. We can now provide an interpretation which will go something like this. So we are 98% confident that the average MPG of cars manufactured in the 5 countries will be between 22.2 and 27.3 miles. Now when you type the interpretation, initially you don't have to worry about how long the line is going to be, whether it's going to be outside of the box or not. Then once you have typed it in, then you can fit the text within the box by highlighting the box and then clicking fill and justify. That will justify the text into the highlighted area.